Welcome back. I want to take a look at some more examples of the substitution rule for evaluating indefinite integrals. I've already pointed you toward the list of examples from which I'm drawing, so yeah, if you haven't already grabbed that in Moodle, what are you waiting for? Go get it! You will notice that worksheet, once you've got it pulled up, go ahead and pause, I can wait. That worksheet is listed in sort of almost what you might call a spreadsheet or a tabular format. It should look familiar if you think back to when we talked about the chain rule. Again, substitutions and the chain rule are kind of the same thing, just from opposite directions. So I encourage you, until you've sort of got your sea legs, so to speak, regarding this stuff, following the format there is perfectly understandable. If you need to divide up a piece of paper into the sections when you're tackling examples, I get it. I've been at this since way too many of you didn't exist, so it's I do it almost don't go specifically off me. Feel free to fill in the entries of the table. I just can't reproduce the whole thing here on this little whiteboard. Anyway, first order of business, you need to figure out what substitution you're going to make to clean things up as much as possible. Remember, the idea here is we want to take something ugly, kind of like this fella right here, and turn him into something we know how to handle via our bestest friend, indefinite integral formulas. Here, from looking at this, this stuff that's underneath the radical, things underneath radicals are a common target. It sort of ends up following from last time where we saw some stuff inside parentheses. Again, yeah, there's a thing. So there's my u, x to the fourth plus 1. Your very next move, once you've identified the substitution, should be to calculate the du piece that you're going to need to go along with it. All right, so du, the derivative here is 4x cubed. The derivative of plus 1, it's a 0, it's a constant. So we have 4x cubed dx. All right, now the next step as suggested on the worksheet is rewrite the integrals so it looks like stuff we can substitute for. So I'm going to do two kind of simultaneous moves here. First, I'm going to take this radical and turn it into an exponent, because that's how we would attack this, right? We would use our buddy the power rule after rewriting this as raising stuff to the 1/2 power. All right, so on the one hand, we have x to the fourth plus 1 to the 1/2. All right. Next, you may be saying to yourself, wait a second, he didn't write the x cubed. You may notice I need this x cubed for my dx. I'm going to haul him back here just like I did in that previous example. So I've got an x cubed, I got a dx sitting in the back. My integral is rewritten such that I can just about execute the substitution. The only thing I'm missing right now is this 4. You may recall I demonstrated this the last time by dividing both sides of this thing by 4. That's not necessarily the only way to approach this. You may notice the worksheet works out our first example with taking a slightly different tack. I'm going to be consistent here and keep utilizing this approach. If you'd like to, see it, a different way, feel free to reach out to me or, reach out to the internet at large. It's got kind of a different mechanism, but, it gets you to the same place. Anyway, so now when I do the substitution, this bit becomes u to the 1/2, because that is precisely, my u right there. This 1/3 dx is going to become, x to the third dx, I said 1/3, I don't know why, becomes 1/4 du. The 1/4 can get hauled out front. I'm not going to rewrite the integral just in the interest of board space, but imagine I pull the 1/4 out front. Now this is u to the 1/2. Our buddy the power rule says we add 1 to our exponent. 1/2 plus 1 is 3/2. I need to divide by my new exponent. Dividing by 3/2 is the same thing as multiplying by 2/3. What am I missing? That's right, I need the plus c, my constant of integration. Okay, I'm technically missing one more thing. Like we saw in the last example, we started with x, and then we got u. That doesn't cut it. We got to put the x expression back in. So 1/4 times 2/3, that should end up giving me 1/6, I believe, if I'm doing my arithmetic right. Spoilers, I am. So then I put this thing back in for u, and magic solution box says be done. Okay, so there's another example. I technically hopped over one in the worksheet. Guess why? So, yeah, it's part of your assignment for this course. All right, so there we go. That's one example down. I'm going to clean up this board real quick. I'm starting to get worried because I really don't like jump cuts, but I'm kind of getting addicted to them. So, yeah, stick around. Different example. Great. All right. This one involves a trigonometric function. We have sine of 4x dx. Yeah, remember, you can't just like yank the 4 out of the sine function. You'd have to, jump through some trigonometric hoops that I don't think any of us really want to jump through. It's easier this way. A substitution will clean this up for us really, really nicely. There's not much here. This is almost not what it's not really what I would call ugly like the other examples. But this stuff inside this trig function, this 4x, yeah, it doesn't match up exactly with the bestest friend formula. So let's call that u. If we do that, then we have sine of u, and that feels smoother, right? As usual, once we got a u, we need the du. So the derivative of 4x is just 4. Write my dx. I don't really need to do much by way of rewriting in this instance. If you want to leave that space blank on the worksheet, that's fine. If you just want to copy this guy back down, also fine. Anyway, so now when I execute the substitution, this part becomes sine of u. The catch is, we've got the dx, we don't have this 4. So, surprise, just like the last example, I'm going to divide both sides of that equation there by 4. So I have 1/4 du equals dx. Great. So I have sine of u times 1/4 du. Ignore the negative for a moment. Yeah. Pull the 1/4 out front. What's an antiderivative of sine of u? Bestest friend tells us it's negative cosine of u. That's where the minus came from. So I'll be a little pedantic here. Again, normally I would have just written the minus out front. Again, if you're in the habit of doing it like this, make sure you're using some kind of grouping symbol so you don't think it's 1/4 and then you subtract the trig function from it. Anyway, so now we've evaluated our integral. The integral signs are gone. We've got our buddy plus c. Now we just got to put it back in terms of x. So negative 1/4. Yeah, I spoiled that. Darn it. Put the 4x back in for u plus c. Check. All right. So, got a trig function down. All right. I want to take a look at one more of these. Again, I'm going to skip over one because, yeah, it's something I expect you to handle in our assignment. But, yep, hang around for just a bit longer and we'll take a look at one more. All right. This one's kind of a step back. It would actually be easier to work this one out by hand than anything that we've done yet because all you got to do is FOIL out that x cubed plus 1 squared thing, but I like substitutions. We need substitution examples. Let's do this. All right. So what do we want to pick here? Stuff in parentheses kind of jumps out at us usually as, pick me kind of thing. So let's go for that. All right. Right after u, find your du. The derivative of x cubed is 3x squared. Write my buddy dx in right there. Now, I'm going to do a little bit more when it comes to rewriting this integral. There's a few different ways you could do it. None of them are really wrong. It's just a matter of personal preference. So when it comes to rewriting this guy, so as is usual, I don't need to do much with this guy. I just kind of write him again. I'm going to move my x squared back here like I've done with some of the other power functions that ended up floating around. The catch is I've got this constant factor of 6 right here. You could technically pull the 6 out front. I'm actually going to break it apart because 6 is 3 times 2. This saves me from having to worry about doing that whole divide both sides by 3 thing, because if I put the 3 right there, I can move the 2 that's the other part of the 6 that's floating around out in front of the integral. And now I don't need to worry about that awkward, division part of this thing. So anyway, still got the 2 out front. This becomes u squared. This whole thing is now an exact match for my du. So it couldn't get much cleaner. 2 times the integral of u squared du. Again, our friend the power rule says 2 times 1/3 u cubed plus my buddy c. So then I've evaluated the integral, convert it back into a function of x. So we have 2/3 times x cubed plus 1 quantity cubed plus c, and we are done with this one. So that's that. All right. So we've talked about indefinite integrals. You may have noticed there's another page to the worksheet that's posted in Moodle. We'll take a look in our next video about how we can extend this substitution stuff to definite integrals rather than indefinite integrals. Look forward to that. I know you are.